All right, for this problem, number 30, we should convert this equation to polar form and then sketch the graph. I think this is a pretty obvious first step. Second step. Third step, maybe rewrite it like this so that we can say that r squared is 4 secant theta cosecant theta. Well, the authors said that r squared is 8 cosecant of 2 theta, and they stopped there. You might have taken the square root of both sides and said that r is a positive or negative square root of 4 secant cosecant, or this. And I would say, great, nice job, well done. Remember though, I said in class that if your answer is different than what the author says, it doesn't mean you're wrong, it just means they used a trig identity. So let's see how we can go from here, what we had for r squared, to what the textbook authors had for r squared. There's this double angle identity you'll see on the inside of your book cover, or you'll see in any standard table of trig identities. It's called the double angle identity. When you have sine of double an angle, you can rewrite it in terms of the single angle. All right, notice that we kind of have in this identity what we have right here, except that they're reciprocals, right? 1 over sine is cosecant, and 1 over cosine of u is secant of u. These are supposed to be thetas. So we're going to use this doubling identity to rewrite our expression. How? We need to take reciprocals of the left side and the right side. So 1 over sine is cosecant. And the reciprocal of this right side is 2 will be on the bottom, and sine will be on the bottom, and cosine will be on the bottom. Or in other words, cosecant of 2 times an angle is the same thing as 1/2 times 1 over sine times 1 over cosine. And now we're looking awfully close to what we have up here, except we need a coefficient of 4, so multiply both sides times 8. We have 8 cosecant of 2u is equal to 4 cosecant of u secant of u. Therefore, 4 cosecant of theta secant of theta is equal to 8 cosecant of 2 theta. There's our r squared. So I'm fine if you had stopped with r equaling the positive or negative square root of the right side. The textbook author wanted you to practice your identities, I guess. And then they ask us to make a sketch of this graph. Well, next they asked us to graph this curve. Well, you can choose which form you want to graph it in. The graph is the same regardless because we superimpose the polar plane onto the rectangular plane. Well, I don't know about you, but I think I'm going to graph this one. So how do we graph this? We can solve y is 4 over x, and that is a hyperbola. You should recognize 1 over x as the parent function parabola. So this is just a parabola that's been stretched vertically a little bit by a factor of 4, but for a general graph, we know parabolas that haven't been reflected just look like this. There's a rough sketch. We're done.